Okay. So what happens, assume that in BJT the temperature is increasing, so the resistance value will start decreasing. So this RT will start decreasing. Okay, since the resistance of thermistor decreases exponentially with increase in temperature. So any increase in temperature will decrease the base voltage IB. See, when the resistance RT is very, very small, current always prefers least resistance path. So yeah, some portion of IB which is entering your base will start flowing towards your RT. So indirectly, what is getting reduced? IB is getting reduced. When IB is getting reduced, IC will get reduced. So by this, I indirectly stabilize the change in IC with respect to temperature. Okay, and I also provide bias stabilization you were using RE parallel to CE. So I will have an emitter resistance which is bypassed by a capacitor CE. So these three will work together to ensure that the collector current is always going to be within the stable limits. It is not going to vary large even the temperature is going to change. Is this simple technique clear? Any doubts anybody is having in the thermistor based compensation? You can ask it now. See, usually we have studied about resistors. Resistors will have fixed resistance. It will not vary. This resistance value is going to be constant. But these thermistors, they're special devices, passive devices, where the resistance will vary with temperature. You have devices called thermistor, you have negative temperature coefficient. Next one we are going to see about sensistor, it will have positive temperature coefficient. So you have devices in both ways, where the resistance will increase with temperature or the resistance will decrease in temperature. Here I am going to use a thermistor which is going to have a negative temperature coefficient. Negative temperature coefficient means as the temperature is going to increase, the resistance value will decrease. And where I am putting this RT, I am putting this RT parallel to R2 in the base side. So now when my temperature is going to increase, this RT will decrease. When the resistance is slowly decreasing, more current will be flowing through RT. So the less current will be flowing through your base. So indirectly I can say IB will reduce. When IB is reducing, IC will reduce. You can ask, when IC is reducing, the transistor will go to cut off? No, because when the temperature is increasing, IC has already increased to a particular value. Because of this RT, it will again come back to its original value. Okay, assume that IC is 2 milliamperes when the temperature is normal. When the temperature is increasing, IC is becoming 4 milliamperes. Without thermistor, I'm saying. But when you have thermistor in base side, when IC will slowly increase to 4 milliamperes, but this RT will reduce, which will ensure that this 4 milliamperes is again brought down to 2 milliamperes. So the collector current is absolutely kept a constant because of this action of the thermistor. Is it clear? Any doubts you have in thermistor based compensation? Any doubts you have in thermistor based compensation method?